Okay, this is the corrections for the Year 8 revision sheet. All right, the first one here is 7.8 centimeters into millimeters. We have a look at the conversion chart that we're given, and there's three options here. There's converting length, area, or volume. So let's have a look. What did the question ask us? It's asked us to convert centimeters, which is a measure of length, into millimeters, which is also a measure of length. So we're looking at this one here. It's asking us to turn centimeters into millimeters. So we can see here that what we have to do is times by 10, because from centimeters to millimeters, we times by 10. So 7.8 centimeters multiplied by 10, we can grab a calculator if we need to. And that is 7.8 centimeters times by 10 gives us 78 millimeters. All right, the next one, 9,000 meters into kilometers. So again, meters is a measurement of length. Kilometers is a measure of length. So we have a look. We don't need the area one. We don't need the volume one. We're looking here at the length. And that was going from meters to kilometers. So we can see here to get from meters into kilometers, we need to divide by 1,000. So we've got 9,000 divided by 1,000 gives us just 9 kilometers. All right, 14,500 centimeters squared. All right, so this is a unit of area. So we'll need a different conversion chart for this one. Unit of area there. And it says to convert from centimeters squared to meters squared. So we can see there is centimeters squared here, meters squared here, and to get there, we have to convert by dividing by 100 squared. See how it says 100 squared there? That's really, really important. So we need to divide by 100 squared. So we go 14,500 centimeters squared, and we are going to divide by 100 squared. Very important that we've got that squared in there. Okay, the next one is a unit of volume, meters cubed into centimeters cubed. Okay, so let's have a look at that conversion chart. So the volume one is here at the bottom, and we're going from meters cubed into centimeters cubed. And we can see in order to do that, we need to multiply by 100 cubed. So we put in 30.5 meters cubed, and we multiply that by 100 cubed. And that gives us a very large number. 305. 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. And now to convert into millimeters, that's going to give us an even larger number. This is going to be quite large. So we have a look at, we have a look at that conversion chart. Where did it go? Here it is, from centimeters cubed into meters cubed. Sorry, into millimeters cubed, I meant to say. We multiply by 10 cubed. So we multiply, we multiply that by 10 cubed, which is 305 0, 0, 0, 0, 0, 0, 0, and I'll run out of space. 0. Okay. Now the last one here, it says to convert to milliliters. So for this one, we look at the bottom here where we have our volume to unit to capacity unit conversion. And we're looking for 1 centimeter cubed is equivalent to 1 milliliter. So we've already found our centimeters cubed. That was over here. And we know that 1 centimeter cubed is the same as 1 milliliter. So this number here will be the same number for our answer. So we can just rewrite this number over there. 305 0 0 0 0 0. All right, and then this last one is 5 milliliters to centimeters cubed. Well, we can have a look at the conversion chart again if we need to, but we should have remembered from that previous question that 1 centimeter cubed is the same as 1 milliliter cubed. 1 milliliter is the same as 1 centimeter cubed. So if we have 5 milliliters, that is the same thing as 5 centimeters cubed. Okay, find the perimeter and area of the shapes below. Well, the perimeter is just adding up all of our sides. So we know that this side is 2.5 meters. It doesn't tell us this length, but we can infer from the other side that it is 2 meters. This side here is 2.5 meters, which means this side over here is 2.5 meters. And then to find the perimeter is just, if I started here and I walked all the way around the object, how far would I walk if I walked right on the edge of that object? So it's the first side, which is 2.5. It's side 1 plus the second side plus side 2 plus side 3. Sorry, side 1, side 2, side 3, plus side 4, which is the first side was 2.5 meters. The second side is 2 meters. The top side is 2.5 and the left side is 2 meters as well. And we plug all of that into our calculator. And we get 2.5 plus 2 plus 2.5 plus 2 equals 9 meters. All right, the area. We'll need a formula for this one. So we have a look at our formula sheet. And what are we looking at? Are we looking at a rectangle, a square, a triangle, a circle? What are we looking at here? So we've got 2 parallel sides and we've got 2 other parallel sides. So that looks like a parallelogram. So we look for the area of a parallelogram and it gives us right here. And the area for the parallelogram is A equals B times H. So we will write that in. A equals B times H. The base is 2.5 right along the bottom. And the height is 1.8. So that is 2.5 times 1.8. And we plug that into our calculator. And we get 2.5 times 1.8 gives you 4.5. Don't forget the units. We're in meters, and because this is area, they are squared. All right, the next one, perimeter. Again, the perimeter is what happens if we walk all the way around the outside. So we've got 4.47 on this side. We haven't been told what that side is. But because it is equal, we can see these little equal dashes. We know that it's 4.47 on all sides. Cool. So we could do this just by, again, adding up every side. And every side is 4.47. You could also just multiply this by 4, but this is a little bit more obvious. Okay, and that gives us 4.47 plus 4.47 plus the next side, which is also 4.47, plus the last side, which is 4.47, gives us, running out of space here, just put the equals here, gives us 17.88 meters. All right, the area. So we've got to think about what shape is this. And hopefully you recognize that it is a rhombus. Remember, a rhombus is a little bit like a parallelogram or a little bit like a kite, but all sides are equal length. So this one here is a rhombus, and the formula we need for this is A equals half xy. So that is A equals half xy, which is half of each diagonal. So we've got one diagonal here, which is 5, and another diagonal here, which is 8. So that is 5 times 8. Half of 5 times 8. And we plug that into our calculator. Don't forget the brackets in the calculator. So that is half. We use the brackets. 5 times 8, close the brackets, and that gives us 20. Don't forget the units. We were in meters, but because we're doing area, it is now meters squared. Okay, find the perimeter of the following composite shape. So we've got a few sides that haven't been given to us. We've been given this side here at the bottom, and we've been given these two sides. We've been told that they're both 3. But we haven't been given this side or the top side or the side over on the right. So we've got 3 sides that are currently unknown. So the first thing to do is to figure those out. Let's start by looking at this top side. If we know that this length here is 3 centimeters and we know that this bottom length here is 2 centimeters, then the top length must be 3 plus 2. We should be able to add those together, and that will give us the top side. So 3 plus 2 is 5 centimeters. And now, because we know that this side is equal to this side, that's what those double dashes mean, then we already know that the right-hand side is also 5 centimeters. And that leaves us with just this left-hand side to figure out. So if we know that this entire length is 5 centimeters and we know that this short side here is 3 centimeters, then what is left over means that this side here must be 2 centimeters. All right, now that we've found all the sides, Finding the perimeter is as simple as adding up all the sides. So we've got, looks like we've got 6 sides here. Side 1, side 2, side 3, side 4, side 5, and side 6. And then we just plug them in. So I'm going to start here with this one and work my way clockwise around the object. So the first side is 5 centimeters. The next side is 5. The next side is here at the bottom. That's 2. Next side is 3. Next one is 3. And then the last one, that little short one on the left, which is 2. And we plug all that into a calculator. 5 plus 5 plus 2 plus 3 plus 3 plus 2 gives us a total length of 20. And because it's just a length, the units are just centimeters. They're not centimeters squared or anything like that. All right. A kite with diagonals of 25 centimeters and 35 centimeters. What area is the kite? So let's start by drawing a kite. This may not be to scale, but that's okay. And it tells us that the long diagonal is 35. So that would mean that this is the longest diagonal, so that's 35. And it tells us that the other diagonal is a little bit shorter, it's 25. So that one there is 25. What is the area of the kite? So we refer over to our area chart, and we can see here that the area of a kite is half xy. So area equals half xy, which is half of the first diagonal, which is 35, and the second diagonal, which was 25. And we plug that into the calculator, and we get half 35 times 25. Don't forget the brackets, and that gives us 437.5. And the units, well, we're working in centimeters, but because this is area, it is centimeters squared. They are squared units. All right, moving on to question 4. Circle the best answer for the following. The height of a horse. Well, 2 millimeters would be a very small horse. 2 centimeters would also be a very small horse. Squared centimeters is a measure of volume, not height. So the only answer must be 2 meters. The length of a calculator. A 15 kilometer calculator would be an enormous calculator. A 15 centimeter calculator sounds about right to me, but let's have a look at the others. A 15 meter calculator, that would also be very long. That's much longer than several cars. And a 10 millimeters cubed, that's a measure of volume. That's not a measure of length. So the only correct answer here must be 15 centimeters. All right, question 5. Write down the formulas for the area of a triangle. This is a super easy one. This is a copy and paste question. So we look at our formula chart. We find the area of a triangle. Area of a triangle is right there. And the formula they've given us is A equals half BH. And all we have to do is write it down. A equals half BH. The area of a parallelogram. Again, they've given it to us right here. And the answer is A equals BH. So we can write it down. A equals BH. The kite. The area of a kite is right here. Half XY. Area equals half XY. So really this is just a question of, can you copy and paste the formula from the formula sheet onto the question sheet? The area of a trapezium is right here. This has got a slightly longer formula. It's half A plus B times H. So that is half A plus B times H. And then the last one here is a circle. And we can see here that we've got two circle ones. We've got a circle one here on the left and we've got a circle one here on the right. But we'll also notice that this one is for the circumference. And that's not what we're after. The one that we are after is the area. That's what the question says. It says write down the formula for the area of a circle. So we need this one over here, which actually looks like it has a mistake in it. Should be A equals pi r squared. So that is A equals pi r squared. All right. Find the area of a kite. Well, we have just copy and pasted the area of a kite formula, so I don't need to go back to my formula sheet anymore. It's half xy. So that is area equals half xy, which is half of the first diagonal, which is 5 meters, and the second diagonal, which is 4 meters, which I plug into my calculator and I get 10 meters. And don't forget its area, so the unit is squared. All right, question 7. Label the parts of the circle. Well, we know that the whole way around the circle is called the circumference. So this arrow here points to the circumference. Cool. We know that this inside part from the center to the outside of a circle is called the radius. So this arrow points to the radius. And we know that from one side of a circle straight across the middle to the other side of the circle is called the diameter. All right. Find the circumference of this circle. So we have a look at our chart. Our formula chart tells us that the circumference of the circle is either pi d or 2 pi r. In this case, we are given the diameter, we're given the full length, so we will use pi d. So the circumference of the circle is c for circumference equals pi times the diameter, which is pi times 16. And we plug that into a calculator. Pi times 16 gives us 50.2654, which is roughly equal to, or approximately to 1 decimal place. And what's our unit? Centimeters. It is 50.3 centimeters. So that means the whole way around this circle is 50.3 centimeters. Let's mark that on the outside on the circumference. All right, the area of a circle. We wrote this one down a second ago. We wrote it down here. Area is pi r squared. Okay. Now we don't actually know what the radius is because we weren't given the radius. We've been given the entire diameter. But the radius is only going to be half that. The radius is only going to be from the middle to the outside. So what is half of 16? Half of 16 is 8. So we have a radius of 8, which we substitute the 8 for the radius. Gives us pi 8 squared. And we put that into our formula. We get pi times 8 squared is 201. Which is roughly equal to 201.1 centimeters squared. To 1 decimal place. Okay, all right, moving on. John wants to turf his backyard. His yard is a rhombus with diagonals of 15 meters and 22 centimeters. I find it's helpful to draw these questions. Well, we know that a rhombus has all equal sides, so it's like a kite, but all the sides are equal. And it's told us that the diagonals are, the long one is 22, so that one looks like the longest one, and the shorter diagonal is 15. So that's 22 and 15. We look at the area of a kite or rhombus down here, and it is half xy. So area equals half xy, which is half diagonal 1, which is 22, times the other diagonal, which is 15. And we plug that into our calculator, and we get half, don't forget the brackets, x, y is 165. Don't forget the units, it is meters, and because we're doing area, it is meters squared. Okay. Moving on to question 10. Find the volume, convert the volume to milliliters and then to liters. All right, we know that we need to find the area first, but helpfully the question's already found the area for us. We have a look at the area conversion chart. The area formula chart, volume of a prism is AH. So that is V equals A times H. A has been given to us, it's 32 millimeters squared, and the height has been given to us, that's 11 millimeters. We plug that into a calculator, we get 32 times 11, gives us 352 millimeters cubed. Now we need to, the second part of this question, it asks us to convert it to milliliters. Milliliters are the same thing as cubic centimeters. So we need to convert from millimeters cubed to centimeters cubed. And to do that, we need to divide by 10 cubed. So that is 352 millimeters cubed. And we need to divide this by 10 cubed. So 352 millimeters cubed divided by 10 cubed gives us 0.352 centimeters cubed, which is the same as 0.352 milliliters. All right, moving on to the next question. This one hasn't given us the area. It hasn't already found the area for us, so we will have to find that. So the area is this triangle here, which has a base of 8 and a height of 3. And the formula for a triangle, the area of a triangle is half base height. So that is area equals half BH, and the base was 8. The height was 3, which gives us 12 centimeters squared. All right. To find the volume was the area times the height, just like we did in the previous question. The volume is the area times the height. Whoops. So we figured out the area of 12 centimeters squared times the height, which is 12 centimeters, which gives us 144 centimeters cubed. Now, because this one's already in centimeters, we don't need to do anything to convert it to milliliters. 144 centimeters cubed is the same as 144 milliliters. Okay. Moving on, question 11. Find the volume of the rectangular prism. Find the volume in liters. Okay, so we can find a face. It doesn't matter which face, actually. I could find this face first, or I could find the top face, or I could find the front face. It really doesn't make any difference which face we find, but I'm just going to start with this one on the end. So area equals 24 times 35. That will give me the area of that face. Which gives me 840 centimeters squared. Then the volume, area times the remaining dimension, which is 840 times the remaining dimension that we haven't used yet is 60. 840 times 60 is 50,400 centimeters square, cubed, because we're in volume now. All right, now we need to convert from centimeters cubed into liters. So we flick back to our conversion chart, and it tells us that there are 1,000 centimeters cubed in a liter. So to find this in liters, I need to divide by 1,000. So we could probably do this in our head, but we divide by 1,000, and that gives us 50.4 liters. All right, moving on. Is this the last page? Yep, last page. Here we go. Question 12. Find the volume of the trapezoid. So again, we find the area of the face. I'm going to start with this one that's facing us. And we look for the area of a trapezium. The area of a trapezium is right here. Half a plus bh. Oops. So that is area equals half a plus b. So we're given a first side of 10. We're given the other side is 6. It's just not written there, but we can see it's the same. So it is 10 plus 6, times a height, which is over here. It's 5 centimeters. And we plug all of that into the calculator. And that gives us half of 10 plus 6 times the height, which is 40. So that gives us an area of 40 centimeters squared. But it didn't ask us to find the area, it asked us to find the volume. So now we need to do the second step, which is volume equals area times h. So that is 40 times the remaining dimension, the height, the only number we haven't used yet, which is 12 centimeters. Gives us 40 times 12 is 480 centimeters cubed. Okay, find its capacity in milliliters. Hopefully by now we're starting to remember that centimeters, 1 centimeter cubed is the same as 1 milliliter. So there is no conversion that needs to happen. To find it in milliliters, we just change the units. So 480 centimeters cubed is equal to 480 milliliters. Convert the following times. Okay. We're actually not going to do the time questions at the moment. We're going to learn time after the exam. So as long as you finish all of the volume and area questions, we're done. So that is the end of the practice paper.